Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on independent events, and I hope you'll be able to see the link between independence and what we learned about conditional probability. So we say that two events are independent if neither affects the chances of the other. So for example, if you toss a coin twice, the outcome of the first coin doesn't matter, doesn't affect the outcome of the second coin. Those two events, what you get on the first go, what you get on the second go, they are independent. So mathematically, two events A and B are said to be independent if and only if the probability of A given B is equal to the probability of A, or of course it doesn't matter if we switch the B's and the A's around. Probability of B given A equals probability of B. If either of these is true, then the two events are independent. So what does this actually mean? Well, probability of A given B equals probability of A. That means B happening, given that B happened, it doesn't change the chances that A happens. If B happens, the chance that A happens is just its normal probability. Similarly, if A happens, it doesn't affect the chances that B happens. So that makes sense in terms of conditional probability. And this is a way we can tell whether or not two events are independent. So we're going to determine whether or not these two events are independent if I roll a normal six-sided die. First event, which I'll call A, I roll an even number. Second event, I'll call B, I roll a multiple of 3. Now, you could probably convince yourself either way that they're independent or dependent, whether or not one affects the other, but we're just going to use maths. We're just going to see whether or not these two things are equal. So we're going to calculate probability of A, probability B, and then A given B. So let's start by calculating the probability of A. So if I roll a normal six-sided die, the probability that the number's even is just a half. 3/6, easy as. The probability I roll a multiple of 3, so there are two ways you can do that. You can roll a 3 or a 6 out of 6 outcomes in total. So it's 2/6 or a third. So the probability that both of these happen, so the probability I roll an even number and a multiple of 3, there's one way that can happen. I would have to roll a 6. That's even and a multiple of 3. One way out of 6 in total. So, because of all of this, the probability of A given B is equal to probability of A and B, which is a sixth, over the probability of B, which is 2/6. So remember, whichever one's listed second, that goes on the bottom, probability of B here. So if you put that on your calculator, you just get a half. What if I calculated B given A? Well, that's very similar. It's the probability of A and B, all divided by the probability of A this time. So that, if you put on your calculator, gives you 2/6 or a third. So in this case, probability of A given B, we calculated as a half. That's the same as probability of A. The probability of B given A, which is 2/6, is exactly the same as probability of B. So because both of these were true, we conclude that these two are in fact independent. So we did it totally using maths. They are independent events. What that means is, if I know that the number I roll is even, that doesn't affect the chances that it will be a multiple of 3. If I know that the number's even, there's still a 1 in 3 chance that the number will be a multiple of 3. Now, just so you know, if I want to check whether or not two things are independent, I don't need to do both of these. If one of these is true, the other will be true. If this is true, then this will be true, and vice versa. So I showed you just for explanation purposes, but once I knew that A given B equals probability of A, I could have stopped there. So please pause and copy this down if you need. I'm now going to check whether this would still be the case if the die was, say, 10-sided. So this time I'm going to do essentially the same question, except instead of being a 6-sided die, it's now going to be a 10-sided die. So I'm still going to let A be the event I roll an even number, B the event I roll a multiple of 3. So we're going to check whether or not they're independent by seeing if probability of A given B equals the probability of A. So what we have here, probability of A, the probability I roll an even number is still a half, or 5 over 10. Now the probability I roll a multiple of 3. So this time I could roll a 3, a 6, or a 9. So the probability I roll a multiple of 3 is 3 over 10. The probability I roll both an even number and a multiple of 3, there's again one way I can do that. I would have to get a 6 out of the 10 possibilities in total. So the probability of A given B, probability of A and B over the probability of B. So once again, whichever is listed second goes on the bottom. Now if I put that on my calculator, I get 1 over 3. This time, I didn't get probability of A given B equals probability of A. They are not the same. So in this case, they're not independent, so we say they're dependent. The chances of each happening depends on the other. What I mean by that is, this time, if I know B happens, if I roll a multiple of 3, it makes it less likely that the number will be even. That's because this time there are 3 multiples of 3, but only one of them is even. So this happening actually did affect the chances of A happening, and that's why they're dependent. So one very important consequence of this rule, if probability of A given B equals probability of A, we're going to use this a lot. It turns out probability of A and B, probability they both happen, is just the product of their probabilities. And that will become very important in determining the probability of compound events. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.